All right, I had a question on how to use the present value of a dollar, present value of a lump sum table, and the present value of an ordinary annuity table. And on the left, we've got a present value of one, or present value of a lump sum. On the right, we have a present value of an ordinary and annuity table. Now, across the top of each table is our interest rate per period. And vertically on the left hand side, we have the number of periods that we're looking at. And in the corner of each here, we have the equation for the present value of one, and over here, the equation for present value of an ordinary annuity. So, with these tables, what we need to do and what we need to understand in at least one way is what we're talking about in rate per period. Now, interest rates are always expressed in the form of APR, which is an annual percentage rate, which means it's essentially expressed yearly. So if we see something at 6%, that's 6% per year. Now, we don't have compounding periods yearly. Sometimes we'll have compounding periods every 6 months, which would be semi-annual. Sometimes we'll have them monthly, which would be, of course, 12 times a year. Sometimes we may have them quarterly, which would be 4 times a year. So in the cases where we have a compounding period that is not yearly, we have to break that down into segments. And what we're talking about these instances, the rate that we're talking about per period, the rate is equal to the APR, or annual percentage rate, and I'm going to rewrite this actually to rate per period is equal to our APR, or annual percentage rate, divided by the number of periods per year. For example, in this case we have 6% per year. Okay, if we're doing that semi-annually, that means we're taking 6% divided by semi-annually is twice per year, which is 3% per period. 3% twice a year is 6%. If we're doing that quarterly, it'd be 6% divided by 4, which is 1.5% per period. If we're doing it monthly, 6% divided by 12 is 0.5% or 0.5% per period. Okay. And that's what we have up here at the top, is the rate per period. Now, the number of periods is equal to the number of years. And actually, let's move this and put this in a different color. The number of periods is equal to the number of years you have multiplied by the number of periods per year. So for example, if we look at something that's 10 years, and we're looking at semi-annual, well, that's 10 years. Semi-annual is twice per year, so that's 20 periods. If we're looking at 5 years monthly, well, 5 years monthly is 12 times per year, so we have 60 periods. Okay. And this is what we get it on the table. So, to look at what does this mean when we're calculating information, especially as it pertains to an accounting with bonds. When we look at these things, let's say we want a basic example, we want to have $10,000 in 5 years, and we can get, or we have an APR of 8% and it's compounded quarterly. Well, in this case, if we want to have $10,000 in 5 years, this is a lump sum. So we're going to use the present value of 1 or present value of lump sum table. If we want to have $10,000 in 5 years and our APR is 8% compounded quarterly, well, how many periods do we have? Well, our number of periods, remember, is equal to the number of years we have multiplied by how many times we're compounding per year. So in this case, if we're compounding 4 times per year, our number of periods is 20. Our rate per period is equal to our APR, which is 8%, divided by how many times we are compounding per year. Compounding quarterly is 4 times, so 8% divided by 4 is equal to 2%. Which means we're going to use our table and we're going to look at the 2% column, which is right here. And within that column, we're going to go down to 20 periods, which is right here. And if we go across, we'll see a number right here, which is 0.6730. So we will take that factor, 0.6730, and multiply it by our future value, or what we need to have in 5 years. And what this means is, if we deposit $6,730, or we invest that, getting 8% per year compounded quarterly, we will have $10,000 in 5 years. That is the present value. This is the present value of $10,000 given 5-year investment, 8% annual percentage rate that's compounded quarterly. Okay? Now, how do we use the present value of an ordinary annuity table? Well, with the present value of an ordinary annuity, the first thing we need to understand is what an annuity is. An annuity is where we have equal payments interspersed over an equal periods of time over a larger period of time. So, if we said we are going to deposit $500 into an investment account, every 6 months for 10 years at, let's say 4% APR. Okay. What's that worth now? What's that worth now? So what we're saying is basically at the end of 10 years, we would have an amount in this account. We're not worried about that right now. What we're saying is we put $500 into this account every 6 months or twice a year for 10 years, and we're getting 4% annual percentage rate. What's the value of all of those deposits into that account over this amount of time and this annual percentage rate done semi-annually? What's the total amount of those deposits worth today? Okay. Now in this case, again, we need to look at how many periods do we have? Okay. Well, we're doing 10 years. Every 6 months is twice a year. So 10 times 2 is 20 periods. Our rate per period, well, we're looking at a 4% annual percentage rate. So we know that's our annual rate is 4%. And we're going to divide that by how many times per year we're compounding. And this is every 6 months, so it's twice per year. So here we're looking at 2%. Now, if we look at our table here where we have 2% column is here. And 20 periods, this might be hard to see, is here. And that is, oh my goodness, 16 point... Let's just make this a little bit bigger, if we can. Whoops, the wrong way. At 20 periods, here we go. We are at 16.3514. So if we take our factor from this table, 16.3514, and we multiply that, remember this is by $500, if we multiply that by $500, this is going to tell us what these deposits over this period of time is worth right now. So 500 times 16.3514 is equal to $8,175.70. That's what we're doing with the present value of an ordinary annuity table. So, I hope this helps illustrate how we use these tables and what they mean and how they pertain to finance. So, have a good day.